Redox and electrochemistry in action. This unit's all about redox type reactions, more specifically how batteries work. Recall in redox reactions that the oxidation and reduction reactions occur when the driving force is a transfer of electrons. Examples that we covered last semester include single replacement, combustion, synthesis, and decomposition type reactions. Today you're going to learn a skill about assigning oxidation numbers which allow us to follow where the electrons are going. There's a list of a lot of rules that you'll become more comfortable with as you go through several examples. The rules are: the oxidation number of any uncombined element is 0. The oxidation number of a monoatomic ion equals the charge on that ion. The more electronegative element in a binary compound is assigned the number equal to the charge it would have if it were an ion. The oxidation number of fluorine in a compound is always -1. Oxygen has an oxidation number of -2 unless it's combined with fluorine when it's +1, or if it's in a peroxide such as H2O2 when it's -1. The oxidation state of hydrogen in most of its compounds is +1 unless it's combined with a metal, in which case it's -1. In compounds, the elements of groups 1 and 2, as well as aluminum, have oxidation numbers of +1 and +2 and +3 respectively. The sum of the oxidation numbers of all atoms in a neutral compound is 0. The sum of the oxidation numbers of all atoms in a polyatomic ion equals the charge of that ion. So let's take a look at some examples. The oxidation number of any uncombined element is 0. So what is the oxidation of H in H2? What is the oxidation of Ne in Ne? What is the oxidation number of O in O2? What is the oxidation number of S in S8? Well, since they're all uncombined elements, and this is how they occur naturally, therefore its oxidation number is 0. The oxidation number of any monoatomic ion equals the charge on that ion. So what is the oxidation number of Cl and Cl-? -1. What is the oxidation number of Na and Na+? +1. What is the oxidation number of Al and Al3+? +3. What is the oxidation number of Ca and Ca2+? +2. The more electronegative in a binary compound is assigned the number equal to the charge it would have if it were an ion. Recall that the electronegative trend is, we have our periodic table. F is the most electronegative element in our elements on the periodic table. So if we have this case, HCl-, we know Cl is the most electronegative, and it's therefore has a -1 charge, so therefore it has an oxidation number which is -1. S is the most electronegative in this case, and it has a charge of -2, so therefore it has an oxidation number of -2. Oxidation number of fluorine in compounds is always -1. So CF4, oxidation number of F, is going to be -1. F in Cl in FCl is going to be -1. F in CH2F2 is going to be all -1. Oxidation number of oxygen is -2 and it's combined with F, which is +2, or in a peroxide when it's -1. So in this case, -2. This is a peroxide, so it's going to be -1. This is just a regular compound, -2. It's a regular compound, -2. It's combined with fluorine, so it's going to be +2. Oxidation state of hydrogen in most of its compounds is +1 unless it's combined with a metal, in which case it will be -1. So this is a regular compound, it's going to be +1. regular compound plus 1, regular compound plus 1. Up, it's combined with a metal, so this is the exception, so it's going to be -1. In compounds, the elements of group 1 and 2, as well as aluminum, have oxidation numbers of +1, +2, and +3 respectively. So lithium and Li2O. Well, lithium belongs to group 1. Remember, group 1 is the first column. Group 2 is the second column on the periodic table. So lithium is going to have a oxidation number of +1. Ca is in group 2, so it's going to have a oxidation number of +2. Aluminum is always going to have +3 as an oxidation number. The sum of all oxidation numbers of all atoms in a neutral compound is 0. So what is the sum of oxidation numbers of H2O2? Well, it's going to be 0. H2SO2, well, it's going to be 0. CaH2, it's going to be 0. Now, to find out individual oxidation numbers, remember the sum, or what they add up to, is going to equal 0. But that means that oxygen is -2, H is going to be +1, but since there's 2 of them, +2. So 2 minus 2 equals 0. H2SO4 has an oxygen is -2, but since there's 2 of them, it's going to be -4. Hydrogen is +1, but since there's 2 of them, it's going to be +2. So sulfur has to be +2 to add up to 0. +2 plus 2 minus 4 equals 0. In this case, Ca is going to be +2 because it's in group 2. H is going to be -1. Since there's 2 of them, it's going to add up to -2. So 2 minus 2 equals 0. The sum of all oxidation numbers in a polyatomic ion equals the charge of that ion. So phosphate, which is PO4, has an oxidation number of -3 since its charge is -3. SO4, or sulfate, has a charge of -2, so it has an oxidation number of -2. The oxidation number of hydroxide, the charge is -1, so therefore its oxidation number is going to be -1. Now, if you take a look at individual ions within this compound, or individual atoms within this ion, you're going to take a look here and you're going to make sure that they all add up. So oxygen has a -2, but since there's 4 of them, it's -8. So what number added to -8 will equal -3, and that's going to be +5. So phosphorus is +5, oxygen is -2. You do the same thing with this. This is -2, which adds up to -8 because there's 4 of them. So then what number added to -8 will give you -2, and that's going to be +6. Oxygen is -2. Hydrogen is always +1. So therefore, -2 plus 1 will give you an oxidation number of -1. Alright, let's take a look here. Go ahead and pause the video and see if you can fill out this chart here, and I'll go over the answers. Okay, so the answers are F2, F is 0, Cl minus, Cl is going to be -1, Na is going to be +1 since it belongs to group number 1. Oxygen is most likely going to be -2. H is most likely going to be +1. O is most likely going to be -2. And since this is a peroxide, H is +1, O is -1. Notice how they all add up to 0 unless they're an ion. Redox terminology. Oxidation is the loss of electrons by a species where the oxidation number is increased. Reduction is a gain of electrons, where there's a decrease in oxidation number. Oxidizing agent is the electron acceptor, where the species being reduced. And the reducing agent is the electron donor, which is the species being oxidized. So how to figure out what is oxidized and what's being reduced? First thing you do is you assign the oxidation numbers to all elements. Find the element with an oxidation number that increases. This element is the one being oxidized. Find the element with the oxidation number that decreases. This is the element that's being reduced. This is how I remember. Reduced, decreased. Okay? And then everything else falls into place. Here's an example. Mg plus HCl goes to MgCl2 plus H2. First thing we do is we assign the oxidation numbers. Mg, since it's by itself, is 0. H is always plus 1. Cl is going to be most likely negative 1. Okay, when it's combined, Mg belongs in group 2, so it has an oxidation number of plus 2. Cl is going to be negative 1. And H2, which is a diatomic element, is going to be 0. The reactant being oxidized is Mg, because Mg goes from 0 to plus 2. The reactant that's being reduced is H+, where it goes from H+ to H2. Oxidizing agent in this case is going to be H+, because the oxidizing agent is the same species that's being reduced. And the reducing agent is Mg, because it's the same species that's being oxidized. Will this reaction occur? Well, the answer is yes. And how do you figure out that answer? For this reaction to occur, you must combine a strong oxidizing agent with a strong reducing agent. The element being reduced must be a stronger oxidizing agent than the element being oxidized. Okay, so how do you figure this out? Well, way back in the first semester, I gave you a reactivity series chart. And this chart, you were able to figure out which one of these was being reduced, which one was being oxidized, and if the reaction will actually occur. So we're just going to take that skill and do it again. Okay, so for this to happen, Mg has to be higher on the reactivity series chart than H, which, here's a reactivity series chart. Mg is a stronger reducing agent than H, so therefore the reaction will happen. Again, you just have to remember that the